Welcome to the next tutorial on current electricity. In this tutorial, I will be solving the problem number 4 and problem number 5. The problem number 4 is show with the help of a diagram how with the help of 1, 2 and 3 ohm resistances you can get 1 6 ohm, to 6 and 6 by 11 ohm and 3 1.5 ohm. Okay. So let me pull a drawing board. Okay, my resistances are 1, 2 and 3 ohms. So let me write it here, 1, 2 and 3 ohms. These are the resistances I have. So if I have to make a combination, from this combination if I have to make 6 ohms, now 6 is equal to 1 plus 2 plus 3. So it is very clear that to get a 6 ohm, I have to connect all of them in series. So connect 1 ohm with 2 ohm and 3 ohm, all holding hand in a series, and that will give a net resistance of 6 ohms. So this part was very easy. Now then question is, how can I get a resistance of 6 upon 11? Now we know that 6 by 11 is less than 1, and in parallel connection the net resistance is always lower than the lowest resistance, and 1 is the lowest of the 3 resistances. So since 6 by 11 is lower than the lowest resistance, and lowest resistance of these 3 is 1 ohm, so this connection has to be parallel. If I have to get a resistance of 611, so this connection has to be parallel. Now let us see, if I connect 1, 2 and 3 ohm in parallel, what the net resistance will be. So net resistance 1 by R is equal to 1 upon 1 plus 1 upon 2 plus 1 upon 3. It is from the law of reciprocals. So it is coming to 6 plus 3 plus 2, which is 11 by 6. Therefore R equal to 6 by 11. So we got exactly 6 by 11 ohm resistance. Okay, let me draw it in a new board because there is no space here. So the resistance 1 ohm, resistance of 2 ohm and resistance of 3 ohm, they are all in parallel, and this will give rise to a total resistance of 6 by 11 ohm. This is 3 and middle one can be 2. So this is the diagram for the second question. Now the third question, how to get 1.5 ohm. This is interesting. Now remember, we have 3 resistances, 1, 2 and 3, and we have to get a net resistance of 1.5. Now 1.5 is exactly half of 3. So we know that if we have 2 resistances of 3 ohms connected in parallel, then net resistance will be half of 3, that is 1.5. So now what we can do is, we can connect 1 and 2 in series, which will give a resistance of 3 ohm as net resistance, and then with this I can connect with this I can connect 3 ohm resistance in parallel. So that means now I have two 3 ohm resistances in parallel. So 1 and 2 should be in series, will give me 3 ohm, and then with this I will connect another 3 ohm resistance in parallel. So let us see what I am talking about here. Let me draw it. So first 2 resistances in series are 1 and 2 ohms, and the single resistance which is in parallel is 3 ohms. So this is 3 ohms, this is 1 and this is 2. These two are in series, so these two will give me a total net resistance of 3. Now I have 3 ohm resistances in parallel. So net resistance 1 by R equal to 1 by 3 plus 1 by 3, which is equal to 2 by 3. Therefore R equal to 3 by 2, which is equal to 1.5 ohm. That means 1 and 2 ohm should be in series, and next 3 ohm will be in parallel. Question number 5. How will you connect 3 resistances 2, 3 and 6 ohm to obtain a total resistance of 4 ohms and then 1 ohm? Okay, let us see how we can get 4 ohm. the resistances I have are 2, 3 and 6. Now if I keep 3 and 6 in parallel, 3 and 6 ohm resistance in parallel will give a net resistance of 2 ohm. And with this I can connect the remaining 2 ohm in series. Now let us see. 3 and 6 ohm resistance in parallel, as I said, it will give a net resistance of 2 ohm. So when 3 and 6 are in parallel, then net resistance from these two will be 1 by 3 plus, we can get by the formula 1 by R equal to 1 by 3 plus 1 by 6, which is equal to 3 by 6, which is equal to 1 by 2. Therefore R equal to 2. That means from these two resistances the net is coming as 2 ohm. Now I have two 2 ohm resistances in series. Therefore the net resistance, the total resistance from this is coming as 4 ohm. Now how to solve the second part? Here I have to get 1 ohm resistance. Now remember, 1 ohm is smaller than 2 ohm and 2 ohm is the lowest of 2, 3 and 6. That means if it is possible to get it when I connect all these three in parallel. So when 2, 3 and 6 are in parallel, then I can write 1 by R equal to 1 by 2 plus 1 by 3 plus 1 by 6, which is coming as 6 by 6, that is 1. Therefore R equal to 1.